second video, we're just going to do, it's only showing me a few minutes, what we have here in the picture, in the under the document camera, rectangular prism. Give you a sense of size by putting my hands in a palm inside there. So made of glass. We've lined it up so that it sits right on this little grid that I made. So right here we have, make that a little bit better. We have the normal coming in, and then you can see the normal continuing into the behind the glass. This is where I'm going to shine the laser on this line. So if it went straight through, it would have gone like this. So my question for you all is, since this is more dense, and this is less dense, so we're going to go from a less dense to a more dense. It's not an MLA, so it's an LMT. So instead of coming straight out about here, it should go back in. And you can see I've cheated a little bit and put a mark where I know it's going to come out. So the quality of this isn't going to be that great. I'm going to try a different camera tomorrow. But I'm going to shine the laser right along that incidence line that I've drawn on there. And you can see that's, I'm on that incidence line. A couple of properties. First of all, we can see the angle of reflection over here. And we can see the angle of refraction inside, right about there. So what we have here is your incidence angle. So let's mark that in. We're going to call that theta I, and then later on we'll call that theta 1, because this is going to be 1. We're going to know that's 1.00. We're going to call this on this side glass, and this is going to be our N2. So we're going to solve for that tomorrow, see exactly what it is for that rectangular prism. What we'll do is, again, I'm going to shine that laser in. See that when I go on that angle, right about here is where it comes out. So I've marked that for us. I'm going to draw that line in. So this is our angle of refraction. So we're going to call that theta 2. And we can just measure that with a protractor, or we can actually do some trig work on it and say, okay, it came out to about, we'll go for a little longer. The longer your distances are, the more accurate your measurements are going to be. So we'll take that, and that would be our opposite. We'll take the measurement of this side, which would be our adjacent, do a tan function, and so we can do it by doing that measurement, or we can just take a protractor and we'll measure that. So we'll try and demonstrate both of those tomorrow, hopefully with a slightly better camera. And that's it for this video. Just shows you again, wanted you just to see for today that idea of refraction, right? I actually demonstrated for you. Actually, yeah, you can actually see it a little better than I even do. Okay, so have a good one, folks.